Another day, another dollar. Asambe subabona. Deep. That's why. Zonke. Okay, guys. So today, guys, I just want us to do exponents and sets, but then we're going to talk mostly about exponents, and later on, that's when we will talk about sets. Okay, so our topic it is exponents and sets. Okay, guys. So exponents and sets, exponents and sets. Okay, I know that this word it is new to your vocabulary, guys, but then you know exponents, right? You know the powers, you know what is the base, you have done them in grade 10. So sets, we'll talk about it later. Okay, so guys, I just want us to remind ourselves what are prime numbers. Okay, so it is very important, it is very, very crucial for you to understand or remember what are prime numbers. Okay, because when you work with exponent, prime numbers will be your friends. Okay, you need to use them so that they can help you out. Okay, so I just have a description of what is a prime number there. So I took it from Google. It says that prime number is a whole number. Okay, so I forgot just to put is there. Is a whole number greater than 1 that cannot be exactly divided by any whole number other than itself and 1. Okay, so let me just try to explain this in my own way. So a prime number, it is any number that you can only divide by 1 in itself. So what do they mean when they say that you can only divide it by 1 in itself? They mean that if you divide it by other numbers, it leaves a remainder. Like for instance, we cannot say that okay, like what are prime numbers? Okay, our prime numbers here, we have 2, we have 3, we have got 5, we have got 7, we've got 11. Okay, so now if you divide 2 by 1, it's gonna give you 2, and then if you divide 2 by 2, it's gonna give you 1 without a remainder. Okay, but then that doesn't mean that you cannot divide 2 by 3. You can divide it, but then it will have a remainder. Okay, it's gonna give you a decimal. Okay, so when they say that you can only divide it by itself and that number, they mean that whenever you divide it, it must give you a whole number. I hope I'm making sense. Okay, so it's 2, it's 3, it's 5, it's 7, it's 11. Okay, why isn't it for a prime number? For you can divide it by 1, it will give you 4. You can divide it by 2, it will give you 2. You can divide it by 4, it will give you 1. Okay, so there are 3 things that you can divide 4 with. So that's why it's not a prime number. Okay, let's check 6. What about 6? Why is 6 not a prime number? You can divide it by 1, you will get 6. You can divide it by 2, you will get 3. You can divide it by 3, you will get 2. You can divide it by 6, you will get 1. Okay, so you can divide it by more than 2 numbers. Okay, so normally prime numbers are those numbers that you can only divide them by 2 numbers, and those numbers are itself. Like for instance, 2, you can divide it by itself, it gives you 1. And then you can also divide it by 1. 2 divided by 1, it's gonna give you 2. Okay, so let's check 7. 7, you can divide it by 1, it's going to give you 7. And then you can divide it by 7, it's going to give you what? It's going to give you 1. Okay, but then you cannot divide it by 3. You can divide it by 3, but then if you divide it by 3, the 3 goes into 7 twice, but then it leaves a remainder of 1. You see? So that's why they say that you cannot divide it by itself. Okay, so I guess you guys understand what our prime numbers are. So it's 2, 3, 5, 7, 11, even 13. It's a prime number. 14 it's not a prime number, 15 it's not a prime number, 16 it's not a prime number, 17 it's a prime number, 18 it's not, 19 it's not, 19, I think 19 it is a prime number. Okay, just confirm with me. Just confirm for me if this one is a prime number. But then I hope you get to understand what are prime numbers. They are very important, guys, especially on this chapter, in this chapter of exponents. Okay, so I think one can ask themselves a question, why are we learning prime numbers? Why are we learning the things that we have learned long ago? It's because of when you are dealing with exponent, it is my advice that make sure that all your bases are your prime numbers. Okay, make any basis a prime number. Okay, so any base, make it a prime number, and then that will make it easy for you to apply exponential rules that we are just going to learn now. Okay, so exponential rules or exponential laws, you guys know them. They are simple but then very important. Okay, so law number one, it looks like this. Law number one, so that's when you multiply the powers of the same base. Remember that this dot means multiplication. When you multiply the powers of the same base, if you see that this base it's a and then that base is a, they are the same, these bases, but then the only different here is this exponent. Okay, so whenever you multiply the powers of the same base, just add the exponent. You take one base to represent the two base, and then there you add your exponent. Okay, so please guys, don't confuse this with when you add them. Okay, we do not have a rule for this one. Okay, so it's not applicable for when you add the powers of the same bases. Okay, so it's not applicable, this one, please know that. Okay, so let's quickly go to law number two. Law number two, it is when you divide the powers of the same bases. Okay, so if we were to say a exponent m divided by a exponent n. Okay, so a exponent m divided by a exponent n. So whenever you are dividing the powers of the same base, you subtract the exponent. Okay, so you take one of the bases. So this a represents those bases that are the same, right? And then you take the exponent on the numerator, not the one on the denominator, the exponent on the numerator, this one, m, minus the exponent on the denominator, n. Okay, so and then please, okay, you can still rewrite this as a exponent m divided by a exponent n. So these two things mean one and the same thing. Okay, it's equals to m minus n. Okay, please, this, let it not be confused with a exponent. I'm sorry about that, guys. Let it not be confused with a exponent m minus a exponent n. Okay, we do not have a rule for that one. Okay, so don't ever take chance and apply the rule for dividing the powers of the same base. Okay, so just know this. Okay, so this rule or this law number two doesn't apply on this one. Okay, when you subtract them. I'm saying this because of I've seen it happening most of the times. Okay, so I'm saying this from an experience, so please don't be confused. Okay, and then now let's just quickly go to law 3. So law 3. So law 3, it's simply when you have a to the exponent m to the exponent n. Okay, so remember that Division means what? Division means multiplication. So this part here, it's the same as m times n. Okay, so if you have something like this, you can write it as a exponent m times n. Okay, quickly let's go to law 4. Law number 4. I don't know why, but then my pen is so slow. So law number 4, we have two bases like this in the bracket, and then we have one exponent outside there. Okay, so you notice that we have two bases, which is a and b, right? Both of them are in the bracket. Both of them, the two of them are in the bracket, and then outside the bracket there's m. Okay, so if it is the case, then if both of them are in the bracket and then outside the bracket it's exponent m, then it means this m, it belongs to each piece or to each base in this bracket. Okay, so you can rewrite it as a exponent m, b exponent m. So what we simply did is that we distributed this m to each base which was in the bracket. Okay, so if it was a different thing, let me just see if it was something like this. Let me just think. Okay, oops. Okay, let's do this. Okay, so it was going to be a different story. So you will check that a, it is out of the brackets. Okay, and then b, it is inside the bracket. Okay, so in this way, the only thing that is going to inherit exponent m, it is b, the one which is in the bracket, but then the one which is outside the bracket will not inherit it. Then this will simplify to be a base b exponent m, like that. I hope I'm making sense. Now let's check law 5. Law number 5. Law number 5. If we have something like this, base a divided by base b, all of them exponent m. Okay, so it's almost similar to that one. Notice that both a and b, base a and base b, they are in the bracket. Okay, so since they are both in the bracket, this m, this exponent m, it belongs to each of these bases which are in the brackets. Okay, so you can simply distribute it and simplify it to be a exponent m divided by b exponent m. Okay, thank you guys. This is part 1 of exponents. Okay, we are just going to dive a bit deeper, okay, into exponents. I will just take some few definitions, and then after that we will do some work based on this. Okay,